Hello, everybody. Hi. Okay. Hi, everybody. I'm very happy to be here today to talk about Huff. So, my name is Clement, and I'm a smart contract developer. So, the first question I'm going to ask you today is what do you know about Huff? Have you already heard about it, or is this something completely new for you? Okay, looks like we have a lot of beginners, so it's going to be cool. All right, so the question that you should be asking yourself right now is, what the hell is Huff? So basically, according to their documentation, Huff is a low-level assembly language for the EVM. So this might be a bit confusing, a bit obscure. So what does it, what does this mean exactly? So basically, when it comes to programming languages for the EVM, for the Ethereum virtual machine, you have different choices, and the most common ones are either Solidity or Viper. So basically, these languages are considered as high level because they're going to take, they're going to do a lot of work for you. When you're coding with Solidity or Viper, you don't have to think about managing the memory or managing the storage. They are going to do everything for you, all of these tedious things. But we do have other languages that are lower level. So for example, we have inline assembly, which is basically the fact of including assembly language within Solidity smart contracts. We have YOL, which is pure assembly that can be used as a standalone to write smart contracts. And then you have more fancy stuff, more fun stuff. For example, Huff, we'll get to that in a bit, and mnemonic bytecode. So let me very quickly show you some examples. So I'm sure everybody here should be already familiar with Solidity code. So very easy to understand, inspired by JavaScript or C. We do have also Viper, which has a Pythonic syntax, also very high level and very easy to read. But then we get into some more complicated but also advanced languages that are offering you more features. For example, with inline assembly, you can manipulate the storage directly or the memory, and you can do that within your Solidity code. Then we have what I've been talking about. It's not very readable, but that's okay. We have YOL, which is basically pure assembly language that you can use and that you can compile in the end using the Solidity compiler. And then we have what we are for here today, the Huff language. So yeah, it looks a bit complicated like this, but don't worry, we'll get to that just after, and you will see that it's quite easy to understand. And just for fun, I'm just showing you. So this is mnemonic bytecode. So we are using directly instructions here and values. So very unreadable. And this is just bytecode. Same thing as the previous one, actually, but all the operations are actually in hexadecimal values. So now you're probably asking yourself, why the hell would I ever want to use Huff? Because it looks complicated, doesn't look easy to read. Well, to answer this question, I'm just going to give you some small history about how Huff was created. So Huff was created in 2018 by the Aztec team. Basically, they were working on a new smart contract that was computing elliptic curves, very complicated algorithm, something that was used previously in Zcash. And they wanted to implement that on the EVM, but neither Solidity or assembly was able to give good results in terms of gas. So they thought about creating a new language, and here's how the original Huff was created. So looks very obscure, very esoteric, and actually, yeah, it's quite esoteric because, as Tech said about Huff, so Huff was designed with a complete disregard for semantics, safety, or basic consistency. Any similarities to production code are purely incidental, and Huff should, on no account, be used by anybody. But this was before. Because what happened recently is that last year, a group of very, very smart and talented developers decided to reboot Huff. So what they did that they took the TypeScript compiler and decided to make a brand new compiler written in Rust. They added new features, they've created documentation, they decided to fix a specific syntax for the language. And so, yeah, like the new version of Huff was created. And so here's an example of what we can do today. Very simple contract. We'll get to that just after. But yeah, Huff recently got traction, especially since the beginning of the year, because all the optimizers on Twitter were talking about it. And also recently, I think 2 weeks ago or last week, they started accepting donations. So yeah, they have many things planned. I have the roadmap here. So basically, yeah, now that they have fundings, they are going to work on new language features, new grammar, many things. Something quite interesting also, the EVM object format support. And yeah, like hackathon workshops, very cool stuff, and also our EPL. So yeah, we'll be able to have fun with Huff. So now I gave you some small details about the history and how it was created and what is it today. So let's get into it, and I'm just going to give you a small introduction. So what can we do with Huff? So basically, Huff is a smart contract programming language. So the goal is obviously to interact with other contracts and to be interacted with. So in Huff, you can declare interfaces, for example, for functions, for events, and for errors. So it works the same as, more or less the same as Solidity would do. And what this will be used for later is that you can generate a signature of your function, for example, and you can use that in the code later. And also, this, you can generate an ABI in Solidity that you can use, for example, for testing or such things. One very cool feature of Huff basically is jump labels. So I'm just going to give you an example. If you tried by any chances to write pure bytecode by hand at some point, the way it works is that when you want to jump somewhere into your code, you will say, okay, I want to jump to the instruction number 22. So you will put 22 and then jump. And you have to be sure that at the position 22 in your bytecode, there is a jump destination. But if at some point you decided to change the bytecode, then you would have to manually change all the destinations and to change all the places where the jumps are happening. So this is very tedious. And obviously, in Huff, we have something quite simple for that. Basically, what we can do is that we just say, okay, here I want to jump to success. And it's just going to say, okay, so success is here. I want to jump. So I'm just going to go here and execute these operations. So this is a very important feature of the language. Then there are some more standard features, such as constants, for example. So you can define one constant variable that you can simply reuse in the code later. Interesting aspects also about Huff is that you can define macros. So it works a bit the same way as uh, like the jump. Basically, at some point, you can decide to jump to a specific macro. So you can define it this way. So hashtag define macro. You can give it a name and say if you want it to receive stack variables or return any stack variables. You just put your code inside of it, and then just going to execute this. So at any point in your code, you can just call your macro, and for example, from here, and then it will jump to the macro. And so the way it works is that when your contract is compiled, every time you're calling a macro, the entirety, so the full macro will be copied inside of your code. So for example, if you want to have a very small bytecode in the end, then it's more interesting to use functions. Because the way of functions are working is that functions will be copied at the end of your bytecode, of your compiled bytecode, and then every time you're calling this function, we are going to jump to the function, execute it, and jump back where we were. So Huff also comes with a lot of very handy features, built-in functions, actually. So for example, let's say you want to get the signature of a function, then you can just use this. So you put 2 underscores and func signature, and then either you put like the actual signature here, the actual function, sorry, or you can use also the define that we saw earlier. So let's say you define the min function, then you can just put min here. And this will generate the function signature. So this is used many times. For example, when you're receiving a call in your smart contract, you want to know which function you're supposed to call. So you're going to use the function signature for that. It's the same thing for events, when you want to emit an event, and error. So these functions are very useful because before we were copy-pasting the function definition in a tool and getting the hash ourselves and copy-pasting back from the website to the code editor. So it wasn't very handy. So yeah, this is just an example with the error. Like we can define errors, custom errors, and then we can just use their signature here. So when you are using the error function, then just going to get the signature.
Another aspect, again, this is very hard to read, so I'm just going to explain it very quickly. But basically, jump labels are going to do switch statements within your code. So let's say you have different scenarios, you work on the function and so on. So if you want to test the value, then you can use them to do switch cases. And this is a bit hard to read and a bit complicated, but basically this shows the way checking function dispatching, so we can get to that. So after showing you all the features of this language, you might be asking yourself, really, is there a reason why we want to do this? And actually, I think there are 2 main cases for Huff. And the first one is obviously educational purpose. If you learn Huff, you will be able, you will have to actually learn about all the opcodes of the EVM. So this is taken from EVM output. Basically with Huff, you're manipulating the virtual machine very low level. So you can use anything that you want. The output, control the code the way you want. So it's like a very nice way to learn how EVM works. And yeah, like you can manipulate the stack, you can manipulate the memory, you can manipulate the storage. Basically, you have to understand how the EVM is structured and how you can do different things. And I think it's quite interesting because if you do some math, even if small example contract, then you would be able to use assembly in your solidity contract or even solidity. And when you use a variable, create a variable, or when you call a contract, you will be able to understand, okay, so I'm creating a variable, so I know that it will be stored in memory. You understand exactly what you're doing. You're not blind, you have like a deeper understanding of the and I'd say the simple use case for Huff is the gas cost saving. So here's a very small example taken from Patrick Collins' Twitter. So basically he created a simple storage contract, just like a smart contract where you can save a variable and get it. And yeah, we see that using Huff is allowing to have like a very nice gas cost saving. So this is for the size of the contract, and this is when you're actually calling the writing. So yeah, you can see that F is very interesting in this case. And obviously this is for a very basic contract, but for example, when it comes to flashbacks, it would be interesting to have very small contracts because you will be able to have like a very cheap transactions, small contracts, and cheap transactions can help you, especially if you're doing. And this is kind of new. So basically, what is affinity? Affinity, as you mentioned, is just a proof of concept. But the idea was suggested like many times in the past. What if you could write something in Huff? So, for example, let's say that I want to do very complicated math operations, but solidity or assembly is not giving me good results. So, can I write all these mathematical operations in Huff, and can I do them inside of my solidity contract? So, before the answer was no, because the only way to do that would be to make a standalone library, standalone Huff contract, deploy it, and then code it from your security contract. So this is possible, but the fact that you have to do like an external call would just increase the gas cost and might just be useless in the end. So what is happening? Basically, the idea was, let's say you are making like a Huff contract, a Huff library. What this proof of concept is doing is that it allows you to insert the bytecode of your Huff code directly inside of your solidity smart contract. Just be able to slice the solidity bytecode and inject the Huff contract inside of it. So it's kind of a way to make like hybrid contracts. I'm not sure exactly how much work is done in terms of if it's ready to be used right now, but this first proof of concept proves that it's a good possible. And yeah, if you just want some small examples about the power of Huff, so this guy just created a lot of Uniswap V2 in Huff. So he wrote like the Uniswap V2 pair contract, but also the fixed point library, everything in Huff. So I'm not going to show the code, but you should check this out, it's pretty interesting. Also, another collection of very cool contracts is called Huffpaint. The idea was to inspire or to pay homage to soulmate, but basically Huffpaint is like a collection of really to use smart contracts in Huff. So let's say you want to make like a ERC20 token, you can use Huffpaint and just like import the ERC20 contract. So everything is ready to use. I'm not sure if it was editing, it was not editing, but it's very nice if you just want to learn from scratch some specific aspects. For example, there is one contract. sort of library dedicated to mappings. Because, yeah, mappings, if you want to use them, you have to write them by hand from scratch. And this is already probably in place, so you can learn how to use it. So when it comes to playing around with Huff or just like combining local tracks, obviously like the easiest way is to use the Huff compiler, which you can install directly, but you will have access to any integration, like testing environment rather than just a compiler. So what is available right now is Foundry Huff, and it's like a new library Foundry that is allowing you to write your Huff contract, and then you can just import it to a security test inside of Foundry. So it's very efficient. Then you can just write on your Huff code, you can just write your own text into the ET, and you run the function test, and then you can see everything is working. Yeah, so I just took this game because I thought it was quite fun actually. So basically, in the end, just some kind of fancy assembly language because all the features that are proposed needs just like synthetic shell that are letting you do things that you could do using if you're writing bytecodes or things. But it's very interesting for educational purposes, as I said. But yeah, also like discussed, even if not aware of many contracts, many projects using have contracts in production right now, but maybe this will happen in the future. So if you want, guys, now we can try to write some math. So, okay, I'm just going to give you like the instructions. So basically, the easiest way to try out Huff right now is to go on this website. So it's the Huff language repository, Huff project template, sorry. And they just added, just going to show you. Basically, they just added like just template button, so you can just use it, and they just going to trade for you this like everything installed like Foundry, etc. So I'm just going to show you this. Okay, so basically if you go on GitHub, yeah, this is the project template, and it's like a ready to use Foundry project. So just have to click this, like use template, create a new repository, and yeah, just going to create everything for you. I've already done it on this side, you can do it on yours. And I think the only requirement is to have Foundry and have compilers installed on the computer. So it's like two commands, basically. This is the installation for Foundry, and this is the installation for the Have compiler. So once this will be done, then you should be having this basically. So it's like a new Foundry project, and you have access here to in source, the source folder to the most like basic example of that. So it's like a simple store. So it's just like a very simple contract. Okay, so this is like one of the most common basic examples for Huff, and it's actually containing very interesting knowledge. So, okay, if you want, we can go through it, and then maybe if you have time, we can work on a small exercise. So, the single store contract, we will here just illustrate a very basic contract that will allow users to save one value and read this value. So very simple, useless in the real world, but it's like the end word for life. So what we are going to do first is contract is that we are defining our functions. So this contract contains two functions. Set value, which is receiving a value and is returning something. And then we have the get value function, which is receiving no arguments, but actually returning the value that we are going to get. So, as I said, when you're defining functions like this, you can use it to either compute the signature of your function, which you have contract, but you can also run make a specific command with the Huff provider, and this will be generated as an API, as an interface that you can directly import into the utility. So it's very useful. Then we have something that is quite interesting. So here we are defining a constant. So I don't know if you remember, but basically we can use like a constant variable in Huff. And we are doing something here. We are calling the free storage pointer function. And this function, what it's going to do is that at compilation time, it's just going to return here the pointer to the free slot in the storage. So I guess in this case, so this will be 0 because we don't have anything. So yeah, we're just assigning value location to 0, and then since the constant, we can just use like this between the brackets, value location, and it's just going to set value every time. So now we have our interface and we have our variable, or at least its location, pointer to this variable. What we are going to do that we are going to write our first Huff function. So it's quite easy. So we are just going to use this function or this one once. So yeah, we can just use the macro because the macro will repeat the bytecode only once. So it makes sense. So let's get to it. We are going to try the set value function. So set value. So the way it works is that when you define your macro, you can say that if you're expecting to have the stack empty, or at the end, if you are expecting to return, you will evaluate the stacks. So here we are not expecting anything from the stack, and we want to have the stack empty. So this is the next way to track the purpose of our functions. So, for example, let's say that we have like an error here, and we are not using the value, or we are adding like an extra value to the slot. Then here we can kind of track and say, okay, so you were expecting to return nothing, to add nothing to the stack, but you actually put values and left values in the stack. Or you use more values that you should. So, okay, so about the content, the set value macro, what we are doing here is quite simple actually. So I don't know exactly if you know how functions are called in stability, but the way it works, let's say I'm going to call the set value function from like my wallet the contract. What is going to happen is that I'm going to generate the signature of this function. So set value is the UIT 256. And I'm going to take the first 4 lines of this hash, and this is called the signature. And what is going to happen is that to this signature, we're just adding all the parameters. So in our scenario, when we want to call the set value function, what is going to happen is that we will have the first byte, that will be the function signature, and then we will have the actual value that we want to send. So it's quite easy to get the value because we say, okay, so we want to load the call data, and we want to load it after the four first bytes. So we're just going to remove the function signature, then this is going to add to our stack value. So this is like a nice way to track the stack of the Ethereum virtual machine. So when you have developers who are using this, just like comments, every time they're adding something to the stack, it just like line by line exactly what is happening. So at first we don't have anything on the stack, so we put our value here. And then what we are going to do is that we say, okay, so we have the value, but we want to store it. So to store it, we have to know what is the location of the variable where we stored. And here comes where the value location, and then this is where the value actually is. So we just put value location in brackets, and this will give us the location that we stored earlier to the free storage pointer from the start. So in our stack, we then have the pointer to the storage, where do we want to store this value, and the value received from the array. And then we just do SS store, and this will store our variable to the storage. Is that clear? Do you have any questions? Maybe we can like break down things from this. I don't know exactly what our level of expertise, so maybe this is a bit confusing. Okay, so maybe we can continue on this. So we have a set value function, and now we want to be able to read this value. So the way it works is actually quite simple here in this case. When we are calling the get function to our smart contract, we are not sending any parameters. So basically, yeah, we're just calling our contract with the function signature of get value. So when we go right into it, we can just say, okay, so the user wants the value that is stored. So, okay, to read, we need to read from the storage, we need to load it. We need to load from the storage at this value location. So here we add the value location to the stack, and here we're just loading the true value at this specific spot. Then what is going to happen is that here we have the value in our stack, but we need to store it in the memory to be able to return it. So we can just put it at the first index, at the first one in the memory, sorry. So we say store, so memory store, this value at the position 0 in the memory. And then this is actually as just returning the value because the user wants to be able to read this value. But it's quite simple to say, okay, we return from the position 0 in the memory, we want to return so 20 in hexadecimal 32 bytes. So since here we just store our value at the position 0 in the memory, here we just return it. And so we created two macros, one to set a value and the other one to get it. But it's not a contract, just two functions. So now what we're going to do, we're just going to make the actual value of the contract. So in Huff, this is made using the main macro. So what is going to happen here? Every time we are calling our contract on the blockchain, then the main macro will be like the attribute. So here, let's say that I'm calling my contract. Okay, so first step is that I want to know which function the sender is trying to execute. So loading the raw data starting from the position 0. And what is going to happen here that we will have in the stack the whole raw data. So as I told you, it will be the signature of the function, but also maybe more values. So what we are going to do here is that we are going to shift to the right the bytes that we receive. So imagine that you have here like your data, you can see like as an array. We say, okay, we only want like the first 4 bytes, but we have 32 bytes. So we are just going to move everything to the right until like it gets like trimmed, and we're only going to keep the 4 bytes. So here in our stack we have some signature, but we don't know exactly what is the signature. So what we have to do is that we have to compare it to our 2 functions here. So we are going to load here the signature of the set value function. And we just compare it here. And it's quite simple here. We say, okay, if the signature that we receive is actually the signature of set value, then we jump to the set jump label. So we go here and we execute this. So we just go there. Same for get value. If it's the signature of get value, then we just jump here and then we execute the get value macro. So this is like a very basic example. And what's happening if someone is trying to call a function that we don't have, then we just revert. And in this case, we revert the hard way because we don't return it, just revert. So this is like the kind of most basic example about what you can do with Huff. But I think it's like a very interesting example because it allows you to manipulate here the memory, and you also read from the storage, and you are handling different cases for the function signatures. So yeah, I think it's like a quite interesting. Do you have any questions? Yes. So basically the way it works is that to be able to return something, you need to store it in the memory. You cannot return it from the stack. So yeah, this is reading from the storage, storing in memory, and reading it from memory. It's the only way to do it. Any other questions? Okay, I do have another example if you still want to check this out. So this is something I brought this morning. It's way simpler. Yeah, I think it's quite interesting because it shows you like how to manage getting values and returning values. So it's the goal of this contract is very basic. You can receive 2 parameters, you can add them, and you choose the value. So it's the same thing as the simplest for example. We're just like defining our function. So I decided to call it compute. And this function is taking 2 parameters, 2 units to 56, and it's going to return like unit 256 also. compute macro. So in this case, then when we are receiving data, what will happen is that we will have 4 bytes for the function signature, and then we will have 32 bytes for the first parameter, and again 32 bytes for the second parameter. So here it's quite simple. We say, okay, I want to know the raw data, but don't give me the first 4 bytes because it's the function signature, so I don't need it. And what is going to happen here that is going to store in the memory, in the stack, sorry, is going to store 32 bytes. So exactly the size of our parameter. So it's quite convenient. And then here we say, okay, so here the value is, it's written 24 in X, so it's like 30 in the decimal. So we say, okay, I want the call data, but I don't want the first 4 bytes because I know it's the function signature, and don't give me the 32 bytes after that because I know it's the first parameter, but I want the second one. So here means that in our stack we will have here the first parameter, and then we have the second one parameter. So what do we want to do with that? We want to do like something simple, an addition. So we just do add. And what is going to happen? We're just going to take one parameter from the stack, then another parameter from the stack, add them together and put it back in the stack. So let's say we have 2 and 3, so we have 5 that will be computed and put into the stack. Then we say, okay, have 5. What do we do with it? So let's store it in the memory at the position 0, because why not? So we say, okay, memory store at the position 0, what we have into the stack. So 5. And then it's the same thing. We decide to return what's at the position 0 in the memory, and we say we want to return 32 bytes. So it's like the standard size for it. So this function is quite straightforward, and here inside of our main macro is actually exactly the same thing as before, except this one is even easier because we just one function. So we get the raw data, we push everything to the right, so we give only the first 4 bytes, function signature. We check if it's really the compute function. If it is, then we jump here, we execute the macro, and if it's not, then we reverse it. So yeah, another type of example of what we can do, quite simple. Yeah. I guess I'm just going to give you a very small extra example, but basically, so the thing is that when we are using, then as I told you, we are using directly macros. So this is where this website is very convenient and useful because you know exactly here what do we have in the stack, what do we need in the stack, and what is going to be added to the stack. So for example, so this is so, for example, in the previous example, I showed you the add operation. So, yeah, we were just taking A and B from this stack. So, like, this stack is just like stacking parameters. So, we take A, then we take B, we put them together, and we put them back into the stack. So, using this website, you can learn about all the uploads. And maybe you can also find some pretty interesting tricks. So, for example, like some Huff developers are using some specific function. Let's say you want to add 0 into your stack. Then you have different choices. You can either do like a push, which is here, or you to push like a value to the stack. But it costs like 3 gas. So you have to do like push 1, zero, or sometimes they're just, for example, if it's the first upload, you can use like a PC, which is like a pointer counter, and like two guys instead of three. So you can have a zero added to your stack at a lower cost. So then you can have some fun playing some of your codes. And if you want to learn also, um, like what the codes are doing exactly, so sometimes when you're coding Huff, you want to have like you want to know exactly what's going on. So you can also use this. So it's a bit tedious. Huff might be supported at some point on this website, but for now you can just like write this debugging micro, but it's quite interesting because it's a really huge things like memory store, things like that. Then you can just run it here. Then you will see what is happening step by step. So you can see the memory, the stack, the storage, the virtual values that are again updated in real time. So it's like a very nice way to also learn about this. So yeah, I think this is it basically. If you want to learn more about Huff, you can have a look at the docs. This is like just a tutorial how to install it on your laptop. But yeah, you have the Foundry Huff. Actually, I show you it. This is the. I don't remember. Yeah, I showed you the. Here it is. The project demo, which I think is the easiest way to practice. And you have examples on this website, but also you have links. And obviously, if you want to chat with us and people, I definitely recommend you have this. So, and this is it. Do you have any extra questions? Yes? That makes sense, but basically when you're using Huff, you're free to do anything, but you don't have any safety net. So it's actually like a quite interesting function. And if you go to resources here, you will see yeah, Huff breakage. And so it's a collection of incorrect breaking and food web contracts. So it's showing that all the comfort that you have with solidity or lightweight, you don't have it in Huff. So if you are doing something wrong, you can save the value, and in the next step you can overwrite it by mistake. And obviously you might catch this during your tests, but sometimes it's not that easy to see issues. So yeah, Huff is very permissive, you can do pretty much anything. Yeah, actually, I recommend you also this list of resources because you have many examples of them. And obviously, style guide. No, not yet. I think like it's quite. The reason is that it's quite complicated to write. It takes a lot of time to write Huff code. It's very risky, and I never heard about auditing here, auditing Huff contracts. So I heard some people were planning to release production code written in Huff, but I'm not sure, and I don't think they've done it already. Maybe in the future, because like Huff at first it was, as they told you, like very, I don't know exactly how to describe this, but it was used by estimators for its own purposes. It was kind of a tool for a few people, but then last year they decided to take it to the next level. Like, there is a very talented team of core developers, contributors, and the community is growing. And maybe at some point people will be able to use it for production, especially for, as I said, like being able to integrate Huff code into Solidity. So I don't know exactly what will be the security implications, but if you write like very basic or scoped math operations, it would be quite interesting, I think, because you can play with the stack, you can do many things. Yeah. Yeah, you can check out Havidity. It's you can check this out by Moodle Zoom. And I haven't checked this like in details yet. So I don't remember exactly how it works. I think it's like proof of concept right now. But I expect it to be released with early before production at some point. That would be very exciting because it's been like maybe for a year that people were talking about this idea. So seeing it now is very exciting. Okay. Thank you very much for your time. Have a good day.